If we look right here, it says find the exact value, sine of 105. Again, 105 isn't on the unit circle, so we want to think of two numbers that add or subtract to 105. It can be any combo. You can write whatever number first. You just want to make sure you're plugging into the formula properly. So we know, for example, that 45 degrees plus 60 degrees add to 105 degrees. So in this case, if we put 45 first, we're going to call that u, and 60 we're going to call v. And we're going to go to the sum of sine formula. So for the sum of sines, it says sine of u times cosine of v. And for sum, this is a plus. Cos of u times sine of v. Now we're going to plug in. So wherever we see u, we're going to plug in 45 degrees. So I'll put 45 here. We'll put 45 here. And wherever we see v, we're going to put in a 60. We'll fill the rest in. So we have sine of 45 times the cosine of 60 plus the cosine of 45 times the sine of 60. Now you're going to go to the unit circle. You can just look at your unit circle to find these values. So you know that the sine at 45 degrees is root 2 over 2. Times, we know the cos at 60 degrees is 1/2. Plus, we know that the cosine at 45 degrees is also root 2 over 2 times the sine at 60 degrees is root 3 over 2. So to add fractions, we want to make sure we've simplified first. So we know this fraction on the left is root 2 times 1, which is root 2, over 2 times 2, which is 4, plus, we know that this fraction over here on the right, root 2 times root 3, you're allowed to multiply, so we get root 6, over 2 times 2 is 4. So now we're going to have root 2 plus root 6 all over 4, and that's our final answer. Can't divide them all by 2. Let's look at the next one. Cos of 165. Find any two numbers that add or subtract to 165. It doesn't matter. You just need to make sure you're plugging into the formula properly. So I could do 120 and 45. The order doesn't matter. Again, you just need to make sure if you do 45 first that the 45 is the u. And you'll get the same answer. So I'm going to call the first number u and the second number v. If I choose to do an addition, two numbers that add to 165, I'm going to do cos sum. So we're going to write the cosine of u times the cosine of v. And if it's a sum problem, we're going to write minus the sine of u times the sine of v. Wherever we see a u, we're going to put 120. Wherever we see the v, we're going to put 45. And I'm going to write cos 120 times the cos of 45 minus sine of 120 times the sine of 45. So we know that the cosine at 120 degrees is negative 1/2. You can look at your unit circle, but you also know that 120 degrees is 90 plus 30. So you're actually reflecting that 60-degree angle, which is 1/2 root 3 over 2, right? So then over here you have negative 1/2, right? All students take calc. So if cosine is 1/2, in the second quadrant, cosine would be negative 1/2. So cosine at 120, negative 1/2. And you can look at your unit circle. Cos of 45 is root 2 over 2. So that's a quantity. Minus the sine at 120 is root 3 over 2. Times the sine at 45 is root 2 over 2. So for this fraction on the left, we have negative 1 times root 2 is negative root 2 over 4, minus, up here we have root 3 times root 2. You're allowed to multiply. We have root 6, even though they're not like radicals, you're allowed to multiply. So we have negative root 2 minus root 6. I like to put that negative in the numerator. All over 4. And that's our answer. We can't go any further. Let's look at the next one. I'm going to erase. We're going to look at the tangent. The tangent's a little tricky, right? So we can decide two numbers that add to 15 or subtract to 15. So I'm going to write up here, I'm going to cross this off because we're doing number 3. And I'm going to put tan 15 degrees way up here. And we'll write number 3 so that we have lots of space. Because tangent problems take up a lot of space. So can we think of any two numbers that add or subtract to 15, numbers on the unit circle? We can do 45 minus 30. 45 and 30 are numbers on the unit circle. So let's write this out. So tan, if I know tan of u minus v, the difference formula for tan, that formula is tan of u minus tan of v all over 1 plus, careful with those signs, tan u times tan v. Now we're going to figure out what u and v are. So u is the first number, v is the second. So wherever we see a u, we're going to plug in 45. And wherever we see a v, we're going to plug in 30. So now we'll have the tangent of 45 degrees minus the tangent of 30 degrees all over 1 plus tangent of 45 degrees times the tangent at 30 degrees. If we come over to the unit circle, we have 30, 45, 60. 30, 45, 60. So the tangent at 30 is root 3 over 3. Tangent at 45 is 1. Tangent at 60 is root 3. So tan of 45 is 1. I'm going to write it over here. So tan of 45 is 1 minus tan of 30 is root 3 over 3 all over 1 plus tan of 45 again is 1 times tan of 30 is root 3 over 3. Now this is messy, yes, but now we're down to algebra skills, right? We need to have one value in the numerator, can't have two expressions, one in the denominator, then we can change division to multiplication and go from there. So let's work on simplifying the top. So we'd have 1 minus root 3 over 3. We can put this over 1, multiply by 3 to have the same denominator. So up top here we'd have 3 minus root 3 over 3. And for the bottom in the denominator, we would have 1 plus 1 times root 3 over 3. Now we need to order of operations. We have to do this first, right? 1 times root 3 over 3 is root 3 over 3. Now be careful, because if that was a half or something, you wouldn't do 1 plus 1 for 1 plus a half first. You would do like a half times root 3 and then you add 1. So now we'll add 1, make denominators the same. So the bottom is 3 plus root 3 over 3. You can't cancel these 3's. All 3 terms aren't divisible by 3. Okay, so now we have on the top 3 minus root 3 over 3 divided by the denominator 3 plus root 3 over 3. We're going to change division to multiplication, so we'll have 3 minus root 3 over 3. If we change to multiplication, we flip the fraction on the right, so 3 over 3 plus root 3. Now we have this quantity, this quantity. If we extend that multiplication line, those 3's cancel, right? The 3 minus root 3 and 3 plus root 3 aren't the same, so they don't cancel. So now we have 3 minus root 3 over 3 plus root 3. You can't have radical in denominator, so you need to rationalize. If I multiply by root 3 over root 3, don't do this right now. I'm just showing you what would happen. If I did this, I'd have 3 root 3 plus 3. I'd still have a radical in the denominator. So I can't do that. You have to multiply by the conjugate, right? You change the sign to the opposite. So it has to be a minus to get rid of the radical in denominator. What you do in denominator, you have to do on top. So in the denominator, if we were to distribute, we'd have 3 times 3 or 9. 3 times negative root 3 would be negative 3 root 3. Then root 3 times positive root 3 is 3 root 3. Positive root 3 times negative root 3 is negative 3, right? Root 3 times root 3, it's gone. These cancel. So we'd have 6 in the denominator, right? 9 minus 3. Now let's work in the numerator. So we have to FOIL. 3 times 3 is 9. 3 times root 3 is 3 root 3. Negative root 3 times 3 is negative 3 root 3. Oops, this should be a negative. So 3 times 3 is 9. Negative root 3. Yep, okay. And negative root 3 times negative root 3 is positive 3. So up top we can combine like terms. Negative root 3 and negative root 3 is negative 6 root 3. Plus 3. We can combine our 9 and 3, that makes 12. So we can erase that and write 12. So 9 plus 3 got us 12. Now, all 3 terms are divisible by the same amount, right? 12, negative 6 root 3, and 6 all divide by 6, so we can do that. So 12 divided by 6 is 2. Negative 6 divided by 6 is negative 1, so negative 1 root 3. And 6 divided by 6 is just 1, so 2 minus root 3 is our final answer.